Continuing the topic, speed of sound. The earlier lecture which I posted was about sound. Now, in this lecture, we're specifically going to talk about how to measure sound. How to measure sound. Now, some data has to be remembered when you're studying about sound and when you're doing calculations for sound. One thing is that sound waves, they travel at a speed of about 340 meters per second. meters per second in air at RTP. RTP stands for room temperature. All right. The higher the air temperature, the greater the speed of sound. Okay. So, and then we talk about the speed of sound in air. When we talk about the speed of sound in air, it has a range. Speed of sound in air has a range. It can go from, let's say, 330 to 350 meters per second. This is the range for speed of sound in air. This data is very important when we are doing calculation for these type of topics. All right. When we talk about speed of sound in materials, and we discussed about the speed of sound in air. Now we talk about speed of sound in different materials: solid, liquid, gas. These are the different type of materials in which sound travels, but sound does not travel through a vacuum. Sound travels at different speeds in different medium, but it travels the fastest in solid, because it travels the fastest in solids. And if we're talking about the fastest, obviously there's the slowest one as well. Sound travels the slowest in what? Liquid or gases? In gases. There's some typical speed for different materials. I'll make a table here, small table. It will be really helpful. Give a name of the medium. Let's say medium. And their typical speed. Okay. So when we talk about gas, the speed of gas is 350 meters per second, as discussed earlier. When you talk about liquid is about 1500 meters per second. All right, 1500 meters per second. So these two informations are really, really important in order to solve questions when you get. Moving forward. Okay. Now, when we talk about different formulas, for speed, for sound, it has to do something with average sound as well. Why is it so? It is because when you're calculating sound, obviously it travels a certain distance. The sound travels a certain distance. So when sound is traveling at a certain distance, you're also measuring the time taken. You're also measuring the time taken for the sound to travel. Yes or no? Yes. I forgot to mention here about solids. The solids will travel at a speed of 5,000 meters per second. Okay, there are basically several experiments that can be carried out to determine the speed of sound. All right, but when you're measuring a sound, let's say a person is standing here. A person is standing here. This person has a clock. This person has a clock. Okay, it's measuring the time. And the other person here standing, this is a kind of experiment I'm showing. Other person standing here, he has two things in his hand and he's clapping, let's say. Okay, let's say clapping. Please subscribe to the YouTube channel for more videos, and in the comment down below you can explain the videos are fine. Any feedback, I would love to hear it from you guys. Now in this scenario, if a person is standing at a distance of, let's say, 10 meters, distance of 10 meters, if a person or more, 10 meters or more, anyways, if the person is standing and the person is clapping here, so obviously the person here is hearing a sound. So that person will measure the speed of sound between the two of them. All right, so this person has a timer, a clock, and that person has a timer of when the sound was heard, and it's calculating the distance. So how do you calculate the speed of sound? There's a formula which says speed of sound is equal to the distance traveled by the sound. The distance traveled by the sound divided by the time taken. Why is it the distance travels? Because if he is clapping at this position, obviously this is his distance traveling. Okay, so when he's clapping, it takes time for him to hear the sound which this guy is making. So this guy is clapping at this point, and the other guy, it's taking time for the sound to reach to his ear. So that thing we call it as time taken and the distance being traveled. And by having all these values, you can calculate the speed of sound. Similarly, in a different scenario, mostly students ask that if we have two sounds, when do you hear two sounds? You hear two sounds when there is echo. If you are in an empty room, let's say if you are in an empty room and you clap, you might hear the sound twice. Not might, you will obviously hear the sound twice. Why? Because the wall is echoing around the wall. The sound, my bad, really sorry. The sound is echoing behind the sound is echoing basically around the walls. All right, so what happens there is you hear the sound twice. So when I talk about twice, the formula will be the same which we discussed here earlier, but there will be a small change. In these kind of scenarios, when you're hearing an echo, what you do is speed of sound. All right, and since you're hearing an echo, there will be two distances. Why two distances? I'll explain it to you. Obviously, you're clapping, the sound is traveling to here, and then it's coming back again, so this person is hearing the sound twice. So two distances. Yes, he is clapping, goes to the wall, hits the wall, comes back again. That thing is called as echo. So you're hearing the sound twice. So in this formula, you will have two distances. Now, how will I put that into the formula? Very easy. 2 times the distance to the wall. Distance to the wall, and then you divide that by the time taken again. For time taken, you will have only one value. Why? Because it's only calculating when the sound is being heard. Okay, the sound, you're not calculating the time twice, because when you're clapping only once, but you're hearing the sound twice. So the time taken will be calculated only one time. Now, in more scenarios where you have more values, you get to calculate the average time. So for average time also there's a formula. It is average speed equals to the distance moved divided by time taken. You can like earlier how I taught you in previous lectures, to easily calculate, remember these formulas, just remember the triangle method. Just remember one of the formulas, and then you can input it into the triangle. How we do it, if this is the average speed, I named it as AS, distance and time taken. So in order to find the time taken, distance divided by average speed. In order to find the distance, average speed multiplied by time taken. So this triangle method is really good. Just remember one of the formulas, and then you can do it really easily. I hope this lecture was clear. See you in the next lecture.